Hello and welcome to this Co-Evolve webinar where we'll talk about WAN optimization for next generation applications. My name is Kieran Roach. I'm the CTO of Co-Evolve and I'm also one of the co-founders of the business. Our presentation today will last for around 35 minutes and we've left some time at the end for any questions that you might have. You can submit questions through the webinar chat interface on your screen and we'll collect those questions and answer them at the end. We'll also be recording today's presentation and we'll email everybody a link with the content afterwards. Before we get into the details, a very brief background about myself. As I said, I am one of the co-founders of the Co-Evolve business based in Chicago in the US. And we started the Co-Evolve business about a year ago, in early 2014. And we'll give a brief overview of the Co-Evolve business in a moment. Prior to Co-Evolve, the majority of my experience is in various technical roles in the networking and telecommunications industry. The majority of that with a virtual network operator called Vanco, which then became Reliance Globalcom across the US and the UK. I've also spent some time with a consulting and advisory firm based out of the US, Pace Harman, where we were working with large multinationals on strategy projects and planning procurement processes and so on within their organizations. And all the way back at the early part of my career, I spent some time with a business called Virtual Access, which before it was even called software-defined networking was involved in orchestration tools and systems to deploy wide area networks without the need to go out and configure every device. So even back a long time ago, about 15 years ago, was involved in that type of mentality and that type of next generation network. So the majority of my experience is around enterprise networking, particularly international networking, and within that, particularly internet-based networks, leveraging next-generation technologies to deliver solutions for those enterprises. Also have a lot of experience in the WAN optimization space, designing those types of solutions, developing roadmaps to incorporate that type of technology in an environment, and more recently been heavily involved in some of the initiatives around software-defined WAN, network function virtualization, and so on. All of that within the context of global networks. So worked for my entire career with a lot of large multinationals across many different countries around the world. Brief overview about Co-Evolve itself. As I said, we're about a year old. Our target market is global enterprises that fall into a number of industry verticals, but they tend to have one thing in common, which is they tend to have operations spread out into multiple countries, and as a result, they've got long distances between their users and their applications. And as you'll hear today, that leads to a number of fairly specific challenges and considerations that we're specifically set up to help address. The verticals we do end up working with most commonly because of that are businesses that are operating in far-flung parts of the world. So we do a lot of work with the engineering and construction sector. They're often in emerging markets building the infrastructure in some of those countries, and they need high-quality networks to support the applications their users are operating in those markets. We do a lot of work in the manufacturing sector across all different types of manufacturing, from consumer products to industrial tools and so on. Oil and gas and natural resources, again, because of the remote geographical aspect of it. And then also logistics, technology, professional services. A lot of focus on businesses that have that gap between the end users and the applications from a geographical perspective. We have a management team in the business that has a lot of experience in this industry. So my co-founder of the business, Tim Sullivan, is the CEO of the business. Tim and I worked together for about 12 years across a number of different roles around the world, and both have that very strong, deep expertise in the global networking space. We also have Chris Bregenhoy as our chairman, who brings a lot of financial services industry experience. He's got an accounting background and has a real depth of knowledge around that type of professional services mentality. We have employees and operations currently in 4 countries. So US, Australia, and Singapore, and then also Malaysia, where we have the Co-Evolve Response Center that we'll touch on at the end of the presentation today. And outside of that, we have a very broad network of on-demand consultants and contractors with just a vast range of skill sets that are needed to address particular problems the client might have. So we're not looking around to try to find people when we come across a particular requirement. we've either got the skill set within our core team or we've got that access to that network of consultants and contractors. So we have about 20 full-time employees, and then several times that when you include this network of on-demand resources that we've got. So before we get into the details around WAN optimization, I wanted to spend a few moments talking about some trends that are impacting global networks that we see on a very regular basis as we're talking to these large multinationals around the world. And the first is that there are a number of technology trends that are really influencing the design process and the thought process around global networks. And in some organizations, they put this down to cloud, and some organizations, they put it down to the need for software-defined networks and better orchestration and coordination. In other businesses, it's really the vast scale that has been introduced into their IT departments by the use of DevOps technologies and mentalities, and wanting to apply some of that agility and flexibility to their networking group within their business. But what we're seeing happening, regardless what the specific driver is that the type of networks that need to be designed these days are very different than what we were seeing even 4 or 5 years ago. And this is manifesting itself in a number of different ways. So probably the biggest shift that we've seen over the last few years is that more than ever, traffic is leaving the closed, carefully designed enterprise network perimeter, and it's going to cloud services, third-party applications, and so on. And that is a trend that catches many organizations by surprise because they've built these networks, they've architected them to deliver very predictable performance between their sites, and then they find that 80% of that traffic is now leaving that network and it's being carried on to a third-party destination. And that's quite a shocking thing to realize when you find that you spent a lot of money on an MPLS network, for example, and it's really just being used as a backhaul to get to the internet. And in many cases, it's dropping off that traffic in a very inefficient place from a network topology perspective. So these expensive legacy networks are actually an encumbrance to the performance of many of the applications that are being run by these enterprises. And the traditional service providers and telcos, as is understandable, their focus is on selling capacity on their network, and they still think in terms of statically defined contracts and agreements and networks where you have a certain amount of bandwidth at each site. You've built a closed network around that group of locations, and increasingly that is at odds with what these enterprises are trying to get out of their network environments. Second trend, and this is one that we see very regularly because of the type of businesses we're working with, but it is almost impossible to get a great user experience by accident if you've got long distances involved between the applications and the users. You really need to carefully focus and manage that environment to get the right outcomes and put the right technology and framework in place to get the best performance out of that type of scenario. So the traditional answer there has always been WAN optimization as a layer that you can drop in to improve that performance. And we'll talk today about some of the challenges around that type of technology in today's application environment. The reality is that type of appliance-based model is a very poor fit as you start to look at this hybrid environment with more and more applications and traffic leaving the global network. And it's not just about the appliances, the management model, the smarts that you put across the top of that to interpret the data, to be able to get the most out of those environments, that really needs to include that deep level of expertise around how those traffic flows are working, not just in the old application world, but in the newer hybrid application world as well. And then that leads to a whole separate set of problems that IT organizations face on an ongoing basis as these applications get further and further away from them, which is all of the tools they have internally, whether they're tools provided by their service provider, whether they're tools that they've invested in internally, a lot of those tools aren't giving the level of visibility they need to show user experience and anomalies and events once that traffic is leaving the network perimeter. So there's a real need to get a good level of insight into the performance across that global network on an ongoing basis and empower IT organizations to act on unusual events within that environment. And that extends out then not just into the technical tools, but into things like vendor management, configuration management processes, and so on. All of that needs to be rethought when you're operating in this hybrid application environment. So looking at all of that with the context of WAN optimization in mind, we really believe that there's a need to redefine what WAN optimization means for this hybrid application space. So we can call it WAN optimization 2.0. We're talking today about a WAN optimization as a service approach, and we'll explain in a few moments what that means. Before we get into the detail of that, maybe it's worth just a very brief recap on what we mean by WAN optimization itself. Well, as we all probably know to some extent, WAN optimization is really about the processes, methodologies, and tools that you can put in place on a wide area network to get improvements in the data transfer rate, in utilization levels, in latency and response times of applications and so on. And traditionally, that has meant appliances that are deployed at each of the locations around the network. And those appliances can come from a large number of different vendors. We've listed some of them here as the most common vendors that have offerings within this WAN optimization space. And most of those vendors are appliance-based models that get deployed. So you choose an appliance based on the size of bandwidth, the throughput that you need to optimize, deploy those at each of the locations, and that's what provides the optimization. And at the bottom there, you can see how this is typically represented. You have an appliance at the remote site, appliance at the data center site, and the technology to optimize the traffic then is primarily, or the foundation of it is based around TCP optimization. So it's taking a legacy protocol that's not very well suited to run over long distances and faking the responses back to the application so that they think they're operating over a much shorter path. So in this example, you have two very short purple TCP sessions on the bottom of that diagram. The client thinks it's talking to a server that's right on its LAN. The server thinks it's talking to a client that's right on its LAN. And then in the middle, the connectivity is rebuilt using much more efficient protocols, and compression can be applied across that link and so on. Application-specific proxies can be layered in to get even better performance for a specific application. So this is a pretty tried and tested methodology, and from a technical perspective, if you're operating in this environment, it does work well. We'll talk in a moment about some of the challenges and scenarios where this doesn't work well, but there's really no argument about the technical benefits of this type of approach. And if you look at the detail of what that means, you can see that in almost every type of wide area network, adding WAN optimization will improve the response time of the applications running across the links quite significantly. So on the left here, you can see a representation of this with the source link we've included here, which has a lot more detail on this, but essentially it's showing that even by adding a very modest amount of latency into a link, so 10, 20 milliseconds, you're cutting your throughput down to approximately 10% of what is theoretically possible over that link as soon as there is any fractional amount of packet loss introduced into that link, which on many wide area networks, there is a very minimal amount of packet loss that you do see across these wide area links. So even across those very low error rates, as soon as you start to add 10, 20 milliseconds, you're drastically reducing the effective throughput of that link. And when you get up into long-haul wide area networks in the tens and hundreds of milliseconds, you're down typically to less than 5% of the effective throughput. So there's a real benefit to adding WAN optimization in here, where you can bump it back up to that theoretical maximum by achieving some of the benefits of optimizing those protocols, as we spoke about a moment ago. So the technology benefits are clear. The business benefits, every survey we look at today and every data point we take, every Q&A session we have with an existing client, we hear the need for more and more WAN optimization to be introduced into the network. So, the biggest benefits that enterprises see, this is based off of an IDG survey from last year, they want to get better availability, better application response time. Cost savings is a key driver for WAN optimization, often due to the savings that can be achieved from a bandwidth perspective through compression and so on. But as we'll see in a moment, cost savings are actually one of the big stumbling blocks that many organizations run into with traditional WAN optimization solutions. And the reason for that is that this traditional appliance-driven model is quite CapEx intensive. So there's a need to get WAN optimization into the environment, but what we frequently hear from organizations is that they start down the path, they put a business case together for their critical sites, and they find it very difficult to justify tens of thousands of dollars of capex across smaller locations that perhaps just don't generate that much revenue for the business, but they still have demanding users there. But the appliance model doesn't scale down to a very low level to support those types of locations. You're still talking about a very significant incremental cost for those sites to be able to add WAN optimization. So that's a major challenge with that current environment before we take into account anything new that's happening within the application environment. And what is happening there? Well, as we've said, the big trending change here is the destination of the traffic. So more than ever, leaving the wide area network. We see 78 to 80% of traffic leaving MPLS networks for the public internet across almost all the networks that we have visibility into today. That's a mix of browsing traffic and web application traffic, and the web application traffic and cloud service traffic is significantly increasing as a proportion of that total. And it's gone from a very tiny percentage of that a few years ago to in many cases 50% or more of the internet destined traffic is now critical business application traffic. Another relevant data point, and this is just one application, but across all of the customers and prospects that we have asked about this, 75% of those are either already running or actively trialing Office 365 as a replacement for existing legacy email platforms within their organization. So this is a foundational application for most enterprises, and it has a very dramatic change on the traffic patterns across that wide area network when it's introduced. So you don't go to that particular Exchange server anymore. It goes into a distributed environment. There's a lot of changes to the network routing and traffic paths that come along with an implementation of Office 365. And the biggest fear for many IT departments is that they're not going to continue to get an acceptable user experience when they move to that type of an environment. At the infrastructure level, we see a lot of progressive and innovative IT departments that are identifying workloads and infrastructure in their current environment that is a good candidate to be moved to an infrastructure as a service platform. So we're seeing a lot of increases in the use of AWS and Azure. Microsoft are pushing this quite aggressively on Azure, where they've effectively made it free in some cases to push a base level of infrastructure out to Azure under their newer enterprise agreements. And many organizations are dipping their toe into the water for the first time there because they've got all of these free credits to use within those contracts. So that's great from a server consolidation and infrastructure footprint reduction, but it raises all of these questions then around how that traffic is going to get between the users and this new infrastructure that's sitting out in the cloud. And then all of that is IT driven and IT aware changes that are happening in the application environment. The real challenge is the change in the application environment that's happening outside of IT. So if we look at applications like Salesforce, Workday, SuccessFactors, all of these are becoming critical applications in many IT organizations, but in many cases, IT is not even involved in the procurement decision for these types of applications. And it sounds like something that it's hard to imagine that it would happen, but we've seen large, sophisticated organizations where the sales management team has signed a global agreement for Salesforce.com. 5,000 users will now have to use that as a critical application, and no one has checked with IT to see how this will perform and how it will operate in the current environment. This happens all the time, specifically because these software as a service vendors are their counterparts within the enterprises. They're not the IT organizations, they're the business unit representatives themselves. They're selling to the head of HR, they're selling to the head of finance, they're selling to the head of sales and so on. And IT is often the last organization to be considered there with all of the questions and obstacles that they can raise along the way. So this is a big problem for organizations because it doesn't get to go through that set of checks and balances that IT would like to have it go through in terms of modeling the performance, sizing, bandwidth, and so on. But the expectations are still very high in terms of the user performance that is needed out of these applications. So there's a real trend across all of these towards public cloud, but it's not by any means an exclusive one. So if you look on the right-hand side here, we've collected some data from various surveys, and there's no question that cloud in some form or another is a part of almost all IT organization strategy at the moment. So there's a very strong level of activity around moving applications and infrastructure into cloud-based environments. It's not all public cloud, so we see a real mixture here. The majority of enterprises are looking at a hybrid environment where they're putting some workloads and services into a private cloud environment, and often that's building on existing virtualization work that's been done internally. And then other workloads and applications that are well suited for the public cloud are being pushed out in that direction. And typically what we're seeing is that it's multiple instances of each that are being deployed rather than all into one public and one private cloud. It's a mixture of many different public cloud providers, and in many cases, multiple internal instances of private clouds as well. So it's a fairly complex application environment that we're seeing here, where the trend is much more towards putting applications into the right bucket to deliver a particular business objective. But then, of course, the network needs to keep up with that and deliver the best possible performance. So what does that mean for WAN optimization? Well, if you've got the traditional legacy model where you've got applications sitting in-house, users sitting on that wide area network, and you've got the budget to do it, you can put appliances at each end, and it's as I said earlier, a tried and tested method. You will get a big increase in performance across the type of environment. If you're pushing workloads and infrastructure out to something like AWS or Azure, still possible, and there are virtual instances of most of the major WAN optimization appliances today that can be deployed into the VPC and the Amazon terminology, for example, where it becomes effectively part of that virtual network that's sitting in the Amazon cloud and can optimize traffic to and from that environment. The real challenge is when you start looking at public cloud applications where it's not your infrastructure, you're just accessing a web-based application where all of the stack below that is managed by a third party. You don't get the opportunity to deploy virtual appliances into that environment. There's a handful of exceptions where Amazon, for example, has the ability to optimize some of that traffic. Riverbed have a cloud accelerator platform where you can deploy Riverbeds at your remote sites and then take advantage of a virtual license that will accelerate Akamai and some other traffic. But it's a bit cumbersome for enterprises to take advantage of this, and it's not very widely deployed. By no means can you optimize all of your cloud-based applications in this way. And it all still depends on the need to put appliances out at each site if you want that traffic to be optimized, or you just don't get any of the benefits of this type of optimization. So our belief is that a better operating model overall is needed, and that's a better technical design, a better commercial model that isn't as CapEx intensive, and then also a better operational model to be able to get the real insights into the performance of these applications that are being optimized. And that's really needed in order to support effectively this hybrid application environment that we're seeing. So what do we believe that can look like? Well, the conversations we're having today around this with prospects and clients around the world are very much focused on an as-a-service approach to WAN optimization. So not financially engineering appliances into an environment, but more of an on-demand model where on a subscription basis, we can provide WAN optimization functionality to locations around the world. And our solution leverages existing internet infrastructure that most enterprises have deployed at branch offices and remote sites around the world, where you're taking that existing internet connectivity and instead of building VPNs over that back to a data center and taking that traffic all the way across the internet, we layer in a global optimization platform in the core in between those remote sites and those data centers. We're using core technology here from a co-evolved partner, Ariaka, and we have, through that technology partnership, a global network of optimized POPs that are specifically deployed in markets to take advantage of high densities of business and enterprise users. I'll show you a map in a moment of the location of these optimized POPs. And the intent here is that you, instead of building those VPN tunnels end to end, a VPN is established into the nearest POP. A private network then joins all of these POPs, and then at the far end, the traffic can leave the exit POP and have a short connection over the internet back to a data center, or even a direct connection over just an Ethernet layer 2 connection, for example. So you end up with a scenario where before you even apply optimization, you've got a better path for this traffic to take. It's a more consistent network. Less of it is on the internet and more of it is on an uncongested private network. And as a result, you tend to see big improvements from a jitter and consistency of latency perspective. What we're doing then, within each of the POPs, we have a WAN optimization stack that is applied in there. So as traffic passes through the wide area network, it is now optimized along the way. So we're doing TCP optimization, application proxies, caching, deduplication, compression, and so on of that traffic. And we have a number of very specific aspects to that that can be applied for many different traffic types. So whether it's MAPI traffic for email, whether it's web browsing traffic for a web application, whether it's many other TCP-based applications, Windows file transfer, and so on. So across a whole range of different applications, we've got a number of specific optimizations that are applied to deliver a much more responsive user experience to each one of those applications. So the biggest benefits here, we provide this as an end-to-end service. So we include the monitoring and management of the edge ISP connections. So it's a bring your own bandwidth solution, but we will act as a single entity to monitor and manage that environment across the whole end-to-end network solution. So we become the group that's responsible for identifying faults and events and anomalies within that telco environment, as well as across the WAN optimization piece. And the fact that we're leveraging local ISPs is an important point when you start to look at the economics behind this. And this is a topic we've spent many years as a team looking at, where all of the real innovation in terms of cost per megabit for internet bandwidth and so on, all of that is really happening at the local provider level. They're the first to implement new fiber to the building technologies, to light more buildings, to add capacity in their backbones, and taking advantage of those types of providers and the low cost that they offer means that there's a very high level of functionality at that edge network level and a lot of ability to get high bandwidth connections without paying the traditional global telco rates for this type of capacity. So we end up with a solution that has no capex involved, minimal amount of setup fees, but certainly no traditional capex as you would see for an appliance-based solution. And again, none of the annual maintenance contracts that you see associated with those appliances. You're purely paying for a per meg per month service, depending on how much optimized traffic you want across this network. And it's very scalable, which is another key limitation of an appliance-based solution, where there are many different breakpoints for bandwidth levels where you need to change out the appliance. They've got typical lifespan of just a few years as well, where they become obsolete or they don't support the newest functionality. So we're getting away from all of that and turning all of the optimization piece of this into a software-based optimization where we can improve the end-to-end performance without having to have all of those appliances sitting out of each of the locations. In terms of the global footprint of this solution, we have 25 of these optimized POPs around the world that are all connected by a private core network in between them. And the research that we've done shows that about 95% of enterprise users, based on business population sizes and so on, are within about 20 milliseconds of one of these POPs. So we're always working with our technology partners to look at where additional POPs may be needed in the future, but the current network gets us very, very close to the vast majority of enterprise users around the world. So we're close to the users, but we're also then close to the cloud service providers. In some cases, we're directly connected to them. In the case of Amazon and several of their regions, for example, we have direct connections into the Amazon network, so we actually bypass the internet completely for a lot of that connectivity. But in many cases, we're in the same data centers as Salesforce, Azure, Google, and so on, to allow us to keep the portion of traffic flows really to a minimum as we take traffic across that network and into its destination. And this is a key benefit of our solution, is that we're not just limited to optimizing internal traffic flows. We can very easily optimize traffic flows between edge users, and cloud service providers, and there's a large range of providers that we've researched, and we know exactly what data centers they sit in and can predictably determine the performance that we'll see between the edge location and the cloud service provider. So the key benefits of this solution, by far the biggest benefit is a cost savings one. So we're eliminating the CapEx component of this. We're not using CapEx heavy appliances like a traditional WAN optimization solution. And we have this subscription-based model that on a TCO basis shows significant benefits over a traditional appliance solution running over a traditional MPLS network, for example. So we've got strong business cases around the alternative to MPLS and the alternative to WAN optimization appliances. And when compared to an environment where there are both, it's a very, very strong combination as an alternative that we've got to offer here. So that's kind of the foundational benefit of this type of solution. Then we're providing a solution here that is a better pathway to this next generation of applications. So this is not something that depends on putting appliances into all of your data centers and only optimizing those traffic flows. By default, this traffic is this platform is a solution to optimize traffic that's destined for whatever cloud applications are in use within the enterprise as well. And it's future-proofed in the sense that it's not locked into any of them. It's the geographical spread of the POPs is a major factor in the ability to optimize that type of traffic. So you're not placing a technology bet on whether you'll still be using that cloud provider in 12 or 18 months. As we've got the global network of POPs in here, it means that whatever cloud provider the enterprise is using, we're going to be very close to those. We're leveraging the existing connectivity at the sites, so high bandwidth connections, low cost per meg from local and regional ISPs, and that the ability to access those falling bandwidth prices there is much greater with that type of provider than with a large global telco, for example. We have very, very predictable network performance, and we really see a difference here, even when we're using applications that are not particularly well suited to optimization. So UDP traffic like video, for example, still sees a significant benefit when run over this network because the jitter and latency variation is far, far lower than what you see when you're taking that across what could be a 7 or 8 different ISP set of hops as it traverses from the edge site back to the data center. So we're putting it on a much better path as a result of the private core network in the middle. And one of the biggest ongoing benefits is that we, by default, provide much greater insights into the usage of the environment than is possible to get with even most traditional wide area networks. So certainly compared to your typical DMVPN solution, for example, it's still quite a complex process there to layer in application level visibility, response times, and so on. With this solution, all of that is captured in a real-time set of reports and dashboards where we can show for any given location what is the breakdown in terms of application usage, what are the top talkers, what was the compression ratio that we achieved across each of the different protocols, how's that trending over time, how much traffic was being optimized versus bypassed. All of that can be seen very easily and very intuitively through a web portal interface. So we're providing an element of customer-driven access here, but we combine that then with the interpretation of data from this type of platform coming from the Co-Evolve Response Center and our engineers and senior technical resources monitoring this on an ongoing basis. So we're able to detect trends and events that are happening within this environment, and then we're the ones raising that as a discussion point to talk about, well, what's happening here? Why have the application profiles changed so much? And then we can understand in much greater level of detail what's happening within that environment. The last piece that I think we wanted to make sure was very clear in this type of an environment, and this is something that is often left out of discussions around the software-defined WAN solutions and next-generation WAN solutions, is that there are a lot of benefits to internet-based technology in enterprise wide area networks, but in order to get the benefits of that, it means you've got to go out and sign a lot of separate contracts with a lot of separate ISPs around the world. And We've talked about the benefits of that from a cost perspective, from a technology perspective. One of the biggest downsides of that is you end up with a lot more vendors you need to manage, and they're all completely separate from each other. They all have separate incident management processes, help desk numbers to calls, workflow processes, and so on. And this is something that we hear as being one of the biggest obstacles to really getting the most out of internet-based networking, like we're talking about here today. We've spoken with, just a couple of weeks ago, a large US-based engineering firm where they've got operations in about 30 countries and have moved to an ISP-based model, but they have 50 ISPs that need to be managed as a result. So the overhead associated with doing that, and the fact that it's not a very intuitive process in many cases, is a major concern for global enterprises. And particularly as you start to get into some of the emerging markets where it's just a lot harder to work with these ISPs. So as a result of that, this is an area that we have developed as a core focus area for the Co-Evolve business, where we provide the vendor management solution specifically for locally contracted services like ISPs. And that is everything from the technical component of this, so polling the IP addresses, getting SNMP stats off a router to see if there are performance issues on a circuit. But then all of that is just a flow into an incident management process with every one of those underlying providers. So we can provide a consistent interface to the client with a single point of contact, single help desk workflow process and team that you're dealing with, a single inventory database containing all of the configuration items within that set of ISPs. And behind the scenes, we then provide the day-to-day management of all of those underlying providers on behalf of the client. So they get the commercial benefit of dealing with those ISPs and even contracting for them locally. So we're not aggregating those from a commercial perspective and marking those up. They're still being bought at the local rates, but all of the day-to-day operational management can be handled by the Co-Evolve team as a single entity. So when you combine the benefits of the core networking technology and optimization platform that we've got as part of this solution with the end-to-end vendor management and oversight of all of the ISPs, that becomes a very compelling end-to-end solution for locations that need WAN optimization but are just not very well served by traditional approaches. So where does this all fit in? Just to wrap this up really in terms of our practice areas and core competencies. Well, we help enterprises today across the whole network lifecycle. So everything from the initial assessment and diagnostics around a current state. This is often a key component of that. We've got 40% of our sites with riverbeds today. We'd like to optimize more. We need to understand, what our options are and what we could do to get better optimization across all of our sites. So we're starting with projects like that in many cases. We then have management and reporting, steady state type activities, and then future state optimized solutions then across many of our different practice areas. And these are two of our core practice areas that the WAN Optimization as a service solution really draws from. So we're taking the core WAN Optimization functionality and we're taking the end-to-end network and vendor management solution. All of these environments and all of these practice areas are supported by the Co-Evolve Response Center. So we've got a team of engineers that are cross-skilled across all of these different practice areas, whether it's a unified comms requirement, whether it's a mobility, mobile traffic management solution, whether it's a WAN optimization solution. All of those are wrapped in under a single group that we have responsible for all of this through the Co-Evolve Response Center. So that enables us to be very effective in those engagements and relationships that we have with our clients, not just limiting it to a single practice area. So the question we'll always ask as we start talking to enterprises is, well, where can we help? We have the team of people there. We've got the expertise available to help across a whole range of different types of activities. So whether that's assessing a current environment, performing benchmarking, developing next generation strategies around what does my wide area network need to look like in the next 2 or 3 years. We're helping across unified communication strategies. This is a core area of interest for many of our clients as they start to put more video endpoints out on their user base with link and endpoints like that and need to join all of that back together. So again, this is an area that we're able to add a lot of value in and help enterprises with. And One of the more recent areas that we're helping with is acting as a sounding board and as an advisory group to help develop strategies that take into account some of these emerging technologies like SDN and NFV. CIOs hear about these all the time at every conference they go to, but it's not often clear what that means to an enterprise's actual environment where they need to support real users today, but also have a plan for the next few years. So we're helping make sense out of a lot of those technologies and help introduce them on a controlled phased basis into enterprises as they become more mature. So they're all the areas that we can help with. In the context of WAN optimization, what we would always suggest is that we trial the solution in the current environment. So it helps a lot to see, the portal, see the real traffic, see how this can behave in terms of the end-to-end performance. And we are very well set up to be able to do a trial. Typically in a matter of a week or so, we can get this set up to see how well it works in the current environment. So with that, that's the last slide we've got from a presentation perspective. We do have a couple of questions, so let us just pause to go through those at the moment, and then we will wrap up the session right after that. So the first question from one of our audience members is around the optimization of the last mile component of the solutions. So we talked about the optimized POPs and so on that we've got in the network, but what can we do to optimize the last mile connectivity? The approach we've got there, we've got two different approaches that can be taken. So we mentioned that we're very close geographically to most of the major business centers around the world. So we can mitigate the effects of latency in many cases just by the fact that we're often only 5 or 10 milliseconds away from that nearest POP. And in those situations, you don't see a lot of impact on those very short hops by not optimizing that last mile component. However, we do have a component of the solution where at no additional charge, we can deploy a lightweight endpoint at the site that becomes the device that establishes the VPN connectivity to the optimized POP, and it also acts as an optimization device in its own right. So it becomes the device that local clients sitting on the LAN are communicating with, so that we get the benefits of optimizing the TCP connectivity across that LAN segment as well as the wide area component piece of it. So we break it down in that scenario into 3 segments of optimization. So the LAN side of it, where it's the optimization between the LAN devices and the lightweight edge point that we use, the hop then into the optimized core, across the core, and then repeated the same at the end. So we end up with an ability there, even if we do have locations that are a long way from the optimization network, to extend that optimization all the way out to the edge of the network. So we have another question around the types of optimization that we can offer and the application focus techniques and services that we can provide. So this is an area, as we mentioned, we are providing something that is comparable to a traditional appliance-based solution. So we're performing all of the standard pieces of this in terms of TCP optimization, and the benefits of that will be applied across any TCP application just as a result of optimizing it at the TCP layer. Within the application layer, then, we have a number of application proxies and application-specific optimizations that can be used to amend the performance of a particular application in order to get better performance across the network link as a result. So there's a fairly long list of what those are. As an example of those, we have a MAPI application proxy that can be enabled if it's exchange traffic that's being passed across the link. And what that does is it improves the response time of the MAPI protocol back to the clients that are sitting out perhaps a long way from the exchange server, and then replaces the end-to-end session with an optimized session in the core of that, from the POP to POP essentially is being optimized, and then at the server end we're communicating again with our proxy instead of extending it all the way out to the client. So the end result of that is an improvement in that end-to-end response time of the Exchange application. Another example is our specific optimizations that can be applied for SSL traffic. So we do have the ability to use root certificates to decrypt and then compress SSL traffic as it runs across the network, and then have it re-encrypted at the server end. So even in environments where the traffic is encrypted as it's sent from the client, we can have that securely decrypted in a very controlled and carefully audited way, compressed as though it were regular HTTP traffic, and then re-encrypted then to allow that end-to-end security to be maintained. So there's a long list of application-specific optimization that we're doing, but there's a lot of benefits that can be seen across a range of different applications by turning these on. The one other piece that we do in this space is related to our APM service, or Application Performance Management Service. We do have the ability to directly measure the end user experience of these applications across the wide area network using a range of tools and probes that we can deploy within this service as well. So we can do it in scenarios where we don't have the WAN optimization piece, but by layering in this type of application visibility tool, we can give a dashboard type view showing the end user experience of each application from a sampling of each of the different sites around the world, and then act on anomalies and events that we see in that environment. So we've got a lot of functionality that can be layered into the solution to take advantage of the need to really be on top of that user experience monitoring. So that covers all of the questions that we had in today's presentation. We will have a brief survey that you'll see at the end when we finish the presentation. We'd greatly appreciate any feedback that you might have, whether that's on the presentation today or on any future topics you'd like to hear more about. Hopefully this session has been useful, and we look forward to speaking to you soon. Thank you very much.